In this video, we are going to learning about the normal distribution. So you can know the normal distribution are also known as the Gaussian distribution. It is a probability distribution that is symmetric about the mean and showing that data near the mean are more frequent in occurrence than the data far from the mean. So we are learning about how we can form the graph, how the graph is formed of by using this technique of normal distribution, and will be appear how it can be appeared. Further moving on another slide, there we have the normal distribution is a probability function that describes how the value of a variable are distributed. So in this we are going to know how the values of variables are distributed by this probability function. It is a symmetric distribution where most of the observations cluster around the central peak, and the probability for values further away from the mean taper off equally in both directions. So it is symmetrical where we get the observation cluster around with the central peak and with the probabilities. This value further away from the mean taper off, and it can be equal at both the directions. So the extreme values in both tails of the distribution are similarly unlikely. It is just depend on what type of distribution you are going to done. So next we have the properties of normal distribution. The mean, mode and median are all equal. The curve is symmetric at the center, that is around the mean u. You can say exactly half of the values are to the left of the center and exactly half of the values are to the right. So both gets equal at different sides, that right and left. The total area under the curve is 1, and normal distribution is defined by this equation. So you can see this equation how it can be defined. This was the equation where you get understand how normal distribution will works, where x is a normal random variable, u is the mean, and sigma is the standard deviation, and tt is here approximately 3.14159, and e is approximately 2.71828. So these are the constant values of this. It can be given constantly, and then we can put the values that what type of distribution we are going to make on. We apply this equation. So at next we have its function. The normal is a theoretical distribution specified by its two parameters, as there you can see the unimodal and symmetrical by this equation, that is fx u sigma square and 1 by 2 pi sigma square and the root here, and it was showing this formula. It is used when we are doing unimodal and symmetrical. The mode, median and mean are all just in the middle, as you can see here in this image. First one is unimodal here, and which can show sigma is 1.6 and the another is 10 and 0, while the other is symmetric. There both sides are equal here, and at where we get the line of symmetry here. So this is the model, and it can be used, it can be made by this function. So next we have function 2. There are only two variables that determine the curve, the mean and the variance, as we can see in the image. The rest are constant, as we know the constant values. The 2 is 2, and the pi is about 3.14, and also we know that is by 22 by 7, and e is the natural exponent number between 2 and 3. In z scores, m equals to 0, st equals to 1, the equation becomes this. So it is the equation when we are just using the another function of it, and we can apply the constant value and put the values and use the function. At where it was the negative exponent means that big Z values give small functions values in the tails. So here it was the another function of normal distribution. So I hope you guys you understand about the normal distribution, what the normal distribution is and its functions, the different functions we learn about that. So that's all in this video. Thank you.